Hi, everyone. Thanks for joining us this evening. Tonight, Victor is going to give us a tech talk on message brokers. Victor, when you're ready, take it away.
Thanks, Erica. Hi, everyone. My name is Victor. Welcome to my tech talk on message brokers. And before I begin, I'd like to thank Jeannie and Bracklet for sponsoring this tech talk. Okay, so what are message brokers? A message broker, I'll read this definition. A message broker is an intermediary computer program module that translates a message from the formal messaging protocol of the sender to the formal messaging protocol of the receiver. I could barely say that. It felt like a tongue twister. So I know that was a little confusing, but I promise it'll be clear when we revisit that later. So let's break it down. A message broker is an intermediary program that applications and services use to communicate with each other in order to exchange information. So just picture like the line. I don't know if everyone here is a Costco member, but if you aren't, you should be. It's like when you're coming out with your shopping cart, you have an employee usually directing you to which line. Maybe there's one line, maybe there's 100 lines. And then there's also security checking to make sure that you went through the check through, right? The checkout, that you just don't go wherever you want. So what are the purposes of message brokers? So there's many capabilities. It depends on what you want to focus on, but generally it's to validate, store, route, and deliver messages to the required destination. Not only can applications communicate information in the same language, it can even be in a different language because your message broker can actually have ways of making sure that they can still communicate with each other. Since they're intermediary programs, the sender of the message really has no idea how many recipients there are. It's known as decoupling. So I'll go more into that later. But most importantly, is this delivery trustworthy? It's kind of like the post office. Well, I don't really trust the post office, but that's another story. Message brokers, however, are trustworthy. Recipients receive the message even if they're offline or not active. It's kind of like an email. You don't have to be online to get it. You just, once you come online, you'll get the messages you're supposed to. And also, you might see this in the wild. Message brokers can also be known as integration brokers or interface engines. That might give you a little bit of insight into what they do. So if you see that, it's the same thing. So how do these message brokers actually ensure message delivery? So you can see by this picture here, you have an incoming message, which is then in-queued onto a message queue and then de-queued when it comes out. So this may seem a little familiar to a little data structure known as a queue. So you can go by the concept of first in, first out. So that implies that this needs to be saved somewhere because it's data. So message queues should be saved in memory or hard disk. It will store messages and deliver them. And the order matters. The order of receipt is kept when making deliveries. So very similar to the data structure, you can think of FIFO, not FIFA. That's something different. Okay, so what if a delivery can't be completed? So if the message never sends for whatever reason, this could be a network problem. You can have it be rescheduled for later in the queue. It's totally up to you to program it, and there's a lot of depth when it comes to this. This is very simple. This is a very simplified model of it. In actuality, they're quite complex, which we'll go into a little bit. But it's like certified mail. There has to be confirmed receipt. That's a fundamental feature of message brokers. So what's the benefit of this using a queue in particular? Why not something else? So it's asynchronous. So you can prevent data loss. It still works if connections fail between what's sending, what's receiving. Well, if it's not sending, then it just never gets it. But in terms of receiving, that's what we really care about. And you're separating your concerns a bit because now it's not just one app, one giant app doing all the work. You may have different apps doing different things, and they're all kind of communicating with the message broker to make sure everything gets to where it should be and that they're all able to talk to each other. Now let's revisit this definition I startled you guys with in the beginning. So it may seem a little bit more familiar now, right? A message broker is an intermediary program. So it's something in between two other programs. And it translates a message from one messaging protocol from the sender to another messaging protocol for the receiver. So hopefully we unpacked a decent amount of this definition at this point. Let's keep going. So a few more definitions. We're going to revisit this too, so don't worry about remembering all this. So basic components would include a producer. That's the component that sends the message itself. It's connected to the message broker. There's also something known as a publish subscribe model. We'll talk about this later. In that case, the producer is just called the publisher. Different terminology, but the same type of function. On the flip side, the consumer is the component that consumes messages in the broker. In the publish subscribe pattern, they are instead called subscribers. So just a different word for the same thing. And then the queue we talked about. We'll bring a picture of this later. But let's talk about actual real world examples to kind of bring that home. So a great example of using message brokers is when it comes to microservices. So when you have a microservice architecture used to build a system, there could be multiple microservices at the end of the development. The problem is, like, how do they all talk to each other? You could choose to use a message broker as a central broker, and microservices can then communicate with each other through that. And also, if you need to add another service to this, now instead of having to reconfigure all your microservices and how they link up to each other, you could just reconfigure your message broker. So it kind of serves as that middle gateway between all these microservices. Another thing is REST APIs. When you build a website front end or a mobile application or a REST API backend, you typically are using request response cycles. That's great. But what if you have something that takes like 10 minutes to complete for a calculation or something you're doing? What if the application that receives the request is not there? It's down for some reason. Then you're going to get failures, which maybe can impact your system. So a message broker could be the answer to that, so that you can guarantee that delivery, make sure everything's working as expected. So here's a great example. Let's say you want to send out a message to everyone and some people are offline. Well, if you have multiple queues, for example, even that offline person will still get the message when they come back on because of the queue, and everything will be in order because of that. Internet of Things, basically everything's a smart device these days. For this, I think of the example of like a hospital. I work in healthcare, so I see a lot of examples of devices being connected. So if you have, like, let's say all the pumps in the hospital are all smart devices, which they are. All the monitoring systems are all smart devices. Everything you're using to check out medication are all smart devices, and it's all connected everywhere, right, to each other. So with all these devices and they're all sending real-time data, how can you coordinate all that data and make sure nothing's being lost? So for this huge amount of information, it might not be a bad idea to use a message broker, which is more reliable and more equipped to deal with large streams of information from multiple sources. Interesting fact, a factoid, Kafka was actually, I will go into that. Sorry, I jumped the gun on that one. I got excited. So you can use message brokers as activity tracking for a website. Like, for example, page clicks. I know it's kind of like a little scary that people are tracking your page clicks, but they are. They can be tracked with a message broker. You can save all these things into a topic, which is basically a queue. And this can be then analyzed and tracked, and you can use message brokers to do that. So the fun fact is that Kafka is actually originally made to track website activity, including page views, searches, user uploads. other actions. There's a very high volume of data when it comes to this because messages are generated for every single user action. So there's a lot of data. So overall, I would say the time to use a message broker is when there's a lot of time and resource consuming tasks. And then when a response is not necessarily required immediately, because you're adding like another layer. So there's a queue aspect. So it's not always delivered as soon as possible. It's depending on the queue and things completing. So if you're not needing a immediate response and there's a lot of tasks that are very resource consuming, then a message broker may be a good technology to use in that case. Going back to the basic components, the producer, consumer, and the queue, let's take a deeper dive into some of these models. So here are the two main patterns. There are other ones out there, but we'll just talk about these two for now. The first pattern on the left is a point-to-point pattern, which basically means that there's a one-to-one relationship. There's one sender, there's one receiver, aka there's one producer, one consumer. Each message in the queue is only sent to one receipt and received only once. So why would you want to use this? Maybe there really should only be one. You want that security. Maybe it's a financial transaction and the payment only needs to be done once and you don't need to send it to anyone else. The other model is a publish subscribe model known as PubSub. This is a message queue with a one-to-many relationship. So you may have one sender, which is the publisher, and then you may have multiple receivers, which is known as a subscriber. And this is maybe a good model where, for example, let's say you're in an airport. When an airplane's flying, we know where it is, right? But who needs to know where it is? Actually, a lot of different systems. Maybe the ground crew needs to know where it is. Maybe the control center needs to know where it is. And the public when you're trying to see when your significant other is landing. So those are all potential subscribers, but maybe you just want to have one publisher in that case. So I hope that kind of brings it to the real world a little bit. So what are the pros and cons? Because nothing's perfect. The pros is that message delivery is guaranteed. It doesn't matter if they're offline or not active. System performance could be increased by offloading it since it's asynchronous. Things that are taking a really long time can be processed separately, so you don't affect your main application. And then applications can communicate with each other, even if they're written in different languages with different interfaces, because you can have specific programming to deal with that. The cons is that it could be a substantial learning curve because they're quite complex. Bringing that complexity into your system, it introduces more points of failure. And bringing that complexity furthermore makes debugging a little more challenging because now you're adding more layers. It may be harder to trace it. You may have to debug the message broker itself. And here are some examples of popular message brokers. Kafka, RabbitMQ are both examples. Kafka was created by LinkedIn, and then it was taken over by Apache. It's very popular. And then another one is RabbitMQ, developed by Rabbit Technologies, and since then controlled by Pivotal Software. And interestingly enough, Kafka is built in Java, which is object-oriented, whereas RabbitMQ is built in Erlang, which is more functional. And these are take-home points. Message brokers are intermediary. It allows for a lot of asynchronous processing. And in the end, it really needs to be an engineering decision where you're balancing the benefits of guaranteed delivery, system performance, and cross-language application compatibility, balancing against that increased complexity, difficult debugging, and that learning curve. Here's my references. And thanks for listening to my tech talk.
Awesome talk, Victor. Unfortunately, we are out of time for questions. So with that, could everybody please unmute and give Victor a round of applause?
Nice.
Great job, Victor.
Good job, Victor.
That was dope.